Do you feel the vibes?
Right. So trigonometry is the study of lines, basically, right? Let me see. Okay. So it's the study of the relationship of sides of angles. Now, when you have a triangle, it has three sides. If you were to take a ratio of the lengths of the sides, that is called a trigonometric ratio. Okay, so if you get a right triangle, right, that has sides, 3, 4, 5, and you say, okay, the ratio of this side to this side is 3 to 4, that's a trigonometric ratio. That's all it is. The three most common trig ratios are sine, cosine, and tangent. You've seen them in geometry. Okay. And over there, you were like SOHCAHTOA, remember? Okay, so what did that mean? So the sine of theta, we write it as sine of theta. And remember this angle, you probably didn't call it theta there, did you? You called it A, B, or C. Okay, so usually this Greek letter is what we use for angles. It is theta, like this. And the way in which you draw it is basically a zero with a line in the middle. Okay, theta. It makes the th sound in Greek. Okay, it's not feta, that's cheese. This is theta with a th, okay? Like thin. Okay. So take a look at this triangle. You've got a right angle here, and this angle here is your theta. Okay, now you have three sides to this triangle. Okay, between A, B, and C, which one is the hypotenuse of this triangle? C is the hypotenuse. Okay, between A and B, which one is the side opposite to theta? A. It's opposite because it's not touching theta. And then B is the adjacent side. Adjacent meaning adjoining, right? When you go to a hotel, like with a lot of people, you get adjoining rooms, right? So basically adjacent means touching. So the adjacent side to theta is the one touching theta. So now, if you wanted to find the sine of theta, all you would do is you would take the opposite side over the hypotenuse and you would get A over C. So if the opposite side has a length of 3 centimeters, this has a length of 5 centimeters, it would be 3 over 5. Okay? All right. The cosine of theta is abbreviated cosine like this, theta. Please do not call these sin and cos. We do not do that. It's sine and cosine. It doesn't take that much effort. The cosine of theta is the adjacent side over the hypotenuse, okay? And then the tangent of theta is the opposite side over the adjacent side, okay? So if I had a triangle with sides, 6, 8, and 10, and if I said, hey, what is the ratio between the side that is opposite to theta and the side that is adjacent to theta, it would say, oh, it's 6 over 8. But that's so wordy. Instead, I could just say, what is sine of theta? And you understand that that is supposed to be the ratio of this side to this side. Okay? All right. So these three you learned in geometry. And then, so SOHCAHTOA comes from, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. That's what that comes from. Okay, now, this year, we're going to go further. We're also going to learn about the reciprocal functions. What if you took sine, cosine, and tangent, and you took their reciprocals? Well, that would be the cosecant right? So it's spelled CSC, cosecant of theta, and it's 1 over sine of theta. Secant, 1 over cosine of theta. Cotangent, 1 over tangent of theta. Okay, how to remember this? Cotangent and tangent are easy, right? But then cosecant and sine, secant and cosecant, those don't sound the same. The only way I have figured out to keep it in mind is all of these either start with an S or a C, right? And you have to just match opposite letters. So a C goes with an S goes with a C. That's literally the only way I have. I mean, right? In practice, you just learn. But for now, let's just do it that way. Okay? All right. So let's do this. It says to find the 6 trigonometric functions for angle theta. You have to be given the angle for which you're finding them. Otherwise, none of this works. So basically, we're going to do SOHCAHTOA, right? Okay, so this is the angle theta. I would highlight my angle first. Then what I would do is label the sides. The hypotenuse is always the easiest because it's the bigger one, right? Opposite to the 90 degrees. And then I have opposite and I have adjacent. So sine of theta equal to opposite over hypotenuse, 8 over 17. Then you ask yourself, can I simplify this? You can't, so that's it. Cosine of theta is what over what? 15 over 17. And tangent of theta is 8 over 15. Okay, how to lose points. Oh, you guys have to go. Yeah, you guys have to go. Okay, so, all right, so ways to lose points before we forget. If you drop that theta, so for example, don't write this. If you say this is wrong. You cannot get full credit for this because that never exists on its own. It's like saying, I'm going to the, that is not, you can't, like, you just can't do that, okay? Or I'm going store, like, those don't work, okay? All right, so here we go. The next ones, okay, so this starts with an S, right? So cosecant of theta, you just take the reciprocal. Secant of theta, you just take the reciprocal. Cotangent of theta, you just take the reciprocal. So really, if you just remember your SOHCAHTOA, the rest, you just take the reciprocal. There isn't any math really left to do, okay? Obviously, if there was anything that needed to be simplified, you would take the reciprocal after you simplified it. Okay, so now take a look at this. If tangent of some mysterious angle A is 52, find the values of the remaining 5 trigonometric functions. I'm sorry, not 52, 5 over 2. So what you have to do first is draw a right triangle. Okay, so let's go ahead and draw a right triangle. Okay. When you do that, the first thing you want to do is you want to label an angle A. So first make the symbol for the right triangle, otherwise it's not a right triangle. Then the other 2 acute angles have to be labeled A. One of them, pick any one and label it A. I'm going to pick this one and label it A. Once you've done that, now label hypotenuse, opposite, adjacent. Okay, now, what I'm given here is tangent of A is 5 over 2. Remember SOHCAHTOA? Tangent is opposite over adjacent. So if opposite over adjacent are 5 over 2, that means the opposite side to the adjacent side has a ratio of 5 over 2. Okay? So I label the opposite 5 and the adjacent 2. Okay? Now, to find the other ones, I need to find the missing side, which I can do because I know Pythagorean theorem, right? So let's do the Pythagorean theorem. Exactly. So I'm going to call this x. So I'm going to do x squared, or let's do it the other way. 2 squared plus 5 squared is equal to x squared. 4 plus 25 29 equals x squared. So what's x? Square root of 29. So here x is root 29. Okay, now sine of theta is 5 over root 29. But when I rationalize the denominator, what does that turn into? I multiply by root 29. I multiply by root 29. So that will be 5 root 29 over 29. Okay? All right, cosine of theta. I'm sorry. Oh, no, these are all A's. Sorry. Not thetas, A's. Cosine of A is 2 over root 29, which is 2 root 29 over 29. Tangent was already given, so I don't need to write that. Now, cosecant of A equals, okay, I need to take the reciprocal, right? So be smart about this. If you take this, the reciprocal will already be rationalized, right? So it'll be root 29 over 5. Secant of theta is root 29 over 2. And cotangent of theta is 2 over 5. I'm so used to theta because everywhere else it's theta. Okay? All right? Fabulous. Okay, so use a trig function to find the value of x, round to the nearest tenth. Okay, so take a look at what you have here. You've done this in geometry. You have your angle here, and you've got two sides given. In reference to the angle, you want to label the sides that you are given. So x is the hypotenuse, and 11 is which side? Adjacent or opposite? Opposite. Okay, so if you have opposite and hypotenuse, which of the ratios is that? Sine, cosine, or tangent? Sine. Okay, so I say sine of the angle equals opposite over hypotenuse. Okay, it always has to be sine of the angle. So now multiply both sides by x. So x sine 24 equals 11. X equals how much? 11 over sine of 24. Okay, now go ahead and take out your calculators. Right, so you have to make sure you see this battery symbol at the very top here. You have to make sure right next to it, it says DEG, not RAD. So one thing you can do is you can bring the cursor over there, and you see the little, hand pointing to it, and hit the center button, and it should toggle. Does it? It should go back to degree. If it doesn't, let me know. Okay, so now, I have 11 over sine. Okay, so 11 over. Okay, so where do we find the sine? Right under control, right under the blue button, it says trig. Hit the trig button, press sine 24. All right, so you have 27.0. Any questions? Oh, cancel. Okay, any questions? All right, so let's talk about special right triangles. Again, you saw this in geometry. So when you have a 30, 60, 90 triangle, okay, you have a 90-degree angle, and then the two acute angles are 30 degrees and 60 degrees. When you have this, you have 3 different sizes of sides. One short side, one middle side, and the longest side. Now, the hypotenuse is always the longest side. Okay, so we're going to call that the hypotenuse. Okay, so that's out of the equation. Next, once you've taken hypotenuse out of the equation, you have the 2 legs. One is the short leg, the other one is the longer leg. How do you know which one is which? You look at the angles. This is the smaller angle, right? between the 30 and the 60, it faces the shorter side. This is the larger angle. It faces the longer leg. Okay? So now, the ratio between all these is always the same. The long leg is the short leg times √3. The hypotenuse is the short leg times 2. All right? Or they're in a relationship of x √3 times 2x. If you remember this, you'll always be able to solve these. Now, the 45, 45, 90 has two congruent angles. That means it has two congruent sides. So the hypotenuse is always any of the legs times √2. Okay, so let's do these for a minute. Okay, so look at this. You have the short leg is x, the long leg is x times √3, the hypotenuse is 2x, correct? Okay, that checks. Now, let's find the sine of 30. Sine of 30 degrees, I'm working in reference to this angle here, okay? Now, let's label, where is the opposite side? X √3, or 2x? X. And the hypotenuse, I'm sorry, the adjacent is x √3. So sine of 30 is x over x √3, right? No, it's not. Oh my God. X over 2x. I'm so sorry. Which will be 1/2. Cosine of 30 is x √3 over 2x. √3 over 2. Tangent of 30 is x over x √3, 1 over √3, which is √3 over 3. Okay? Now, let's do 60 degrees. For the 60 degrees, we have to relabel everything. So let's do that. I'm going to erase all this. Okay? So for the 60 degrees, now this is the angle that I'm looking at. So which one is the opposite now? This one, and the adjacent is this. So if I have sine of 60, it's the opposite over the hypotenuse. So √3 over 2. Okay, cosine is the adjacent over the hypotenuse, 1/2. Tangent is the opposite over the adjacent, √3. Okay? What do you notice here? Sine and cosine, and sine and cosine are opposite of the 30 and the 60, right? Okay, so what would be the sine of 45? Oh. So I take one of the 45s. I'm going to take this one. Label opposite, and so tell me, what would the sine of 45 be? X over x √2, which is 1 over √2, √2 over 2. What would cosine be? Same thing. Tangent, 1. Okay, so remember, these are all ratios. So if you have a 45, 45, 90, the ratio between this leg and this leg is 1, because they are the same. So the tangent of 45 is the ratio between the opposite leg and the adjacent leg, and they're 1, because they're the same. Okay, so these ratios are actually known, right? Like eventually you need to get to a point where, like if you're walking down the street and somebody taps you on the shoulder and says, hey, what's tangent of 60? √3, right? You should just know, right? right? What's cotangent of 60? Root 3 over 3. You should just know these things, right? So eventually, that's where we're going to get to. For the time being, you can draw a right triangle and figure it out. Okay, so use a trig function to find the value of x. So here we go. This is what we need to find. I have my angle. This is the opposite. This is the hypotenuse. What ratio is that? Sine. Sine of 60 is x over 12. Okay, but look, what is sine of 60? Right? You see that? We found it before. It's root 3 over 2. So I say, okay, this is root 3 over 2 equal to x over 12. Now multiply both sides by 12. So 6 root 3 is equal to x. Okay? All right. Now, what if, okay, okay. If I see you guys memorizing this chart, I'm going to be very disappointed. Do not ever memorize things like this in math. Let me tell you why. When you're stressed on a test, the first thing you forget is the stuff that you've memorized. Okay? The things that you know are the things that you know. So, you get to this step. Now you have to substitute the value for sine of 60. Oh my God, now you freak out because you forgot the table. It's okay. The person sitting next to you never memorized the table. What they do instead is they draw a triangle. Okay? 30, 60, 90. If this small side is, let's say, 1, how big is the middle side? 1 times root 3, and this is 2. Remember that. 1, root 3, and 2. Now, the sine of 60 will always be root 3 over 2. Okay? So, sine of 60 is the opposite over the hypotenuse, root 3 over 2. So, this is what we know. Nobody memorizes that chart. Do not do that. It's a waste of your time. Okay? You should know this, and it's not going to help you in the lessons later on either. Okay, so now, what if you weren't looking for a side, but an angle instead? In that case, we use inverse trig functions to find the measure of an angle. So, the symbol is this, and it's pronounced sine inverse. So, if you have an angle, and the sine of the angle is 1/2, and you want to say, hey, what is the angle for which the sine is 1/2? You say inverse sine of 1/2, right? So if I was walking down the street and I saw this on a billboard, I would say, oh my God, somebody's looking for the angle, the sine of which is 1/2. And then, you're like, oh my God, Miss Malikan, that's 30 degrees, which it is. Okay? All right, so let's see this. Here we go. Angle, hypotenuse, adjacent. Which ratio is that? Cosine. So cosine of the angle always equals to adjacent over hypotenuse. Okay, so x is inverse cosine of 15 over 17. Okay, now on your calculators, again in degree mode. Okay, you press the trig button here under the control. You have this menu. You find the inverse cosine with the arrows. And then it opens up a parenthesis for you. In there, just put in 15 over 17. So we get 28.07. It says to round to the nearest 1/10, so it's 28.1 degrees. Okay? Huh? I mean, it's nice too, so you don't get it mixed up with any other unit. Okay, so here, you have this. Okay, is the 27 adjacent, opposite, or hypotenuse? And what about the 18? Fabulous. So its tangent of x is 27 over 18. Please, please, please don't go simplifying the 27 and the 18 here, right? It's an intermediate step. Don't make any mistakes, right? Because like you can divide by 9, right? And you get 3 over 2. But what if you mess up? Don't do that. That'll mess everything else up. So x is inverse tangent of 27 over 18. What is that? Fabulous. Okay. So angle of elevation, angle of depression. Okay? Look at that kitty cat over there that's eyeing the bird, right? I know. They just want to be friends, right? They don't have any other intentions. Yeah. They just want to be friends. If there was like a recipe, you know, like a cookbook next to the bird, next to the cat, then we'd be worried. Huh?
What are you getting at?
I mean, it's the food. Okay, so angle of elevation. So this is the eyesight, the horizontal eyesight, or sorry, line of sight of the cat. And it's looking up at the bird. That angle is called angle of elevation. Now the bird is sitting there going, there's no way you're going to catch me, right? This is the line of sight, the horizontal for the bird, looking down at the cat. That is called angle of depression. And if you remember from geometry, how do those two angles relate? Huh? They're not supplements. They're equal, they're congruent. Why? What are they? They're alternate interior angles. Way to go, Eden. Alternate interior angles. Slay. Way to go. Are you gonna have a?
Did you ever think about if you weren't a teacher, maybe you'd be a stand-up comedian?
No.
But you're so funny.
Okay. I would be able to do voices. I imitate people rather well.
Can you give us one?
No.
Huh?
Huh?
Doesn't have to be like mocking someone from the school. Like,
Well, not mocking. Imitation is the best form of flattery. Haven't you heard? Okay, we got to finish this. Angela climbs in their hang glider at an angle of elevation of 15 degrees. Find their change in altitude when they have flown a horizontal distance of 50 feet. Okay? So, there is an angle of elevation of 15 degrees. Angle of elevation is always taken with respect to a horizontal line. Angle of elevation will go up from the horizontal line. So that's 15 degrees. You want to find the change in altitude when they have flown a horizontal distance of 50. Okay, so when you're doing this, when you're dealing with angles and distances, you always have to think right triangle. So now I have this, and I can always turn this into a right triangle. Now, they have flown a horizontal distance of 50 feet. That's this. And you want to find the change in altitude, the vertical distance. And you know what? I'm going to label that y because it's vertical. So what ratio is this? Sine, cosine, tangent? Tangent. Tangent of 15 is equal to what? Y over 50. Well, x too if you labeled it x. So 50 to both sides. So y is tangent 50 times tangent of 15. Okay, so 50 tangent again is in our little trigonometric bar. Yeah, yes, because it's not inverse. 13.4. Good. Right? So by the time they've gone 50 feet, they've gone up 13.4 feet. Okay? All right. So that's section 1 for you all. Okay, so the homework is a worksheet.
Press start.